Let's begin. Now we've done a lot of this already. What I want to do is I want to make sure that we come together with a mutual understanding of what it is that you need to know for your quizzes that are on Tuesday. Iman, all work, right? The worksheet that we're going to do today, yes? The outline and the questions, okay? Iman's making a racket. She's okay about it. Right? That's all due on Thursday, correct? Outline, book problems, and worksheet due on Thursday, correct? And then the test, not the test. The 2 quizzes are on Monday. All right. Do you have a date on that? Shall we put a date on that? Do we have class on Thursday?
Yeah. Yes.
It's a sports day or something, right?
No, we have a half day. Wait.
You have a half day.
Half day this Thursday and sports.
Half day this Thursday. So you're going to have plenty of time to hand your work in, correct? Probably? Yes? If not, it's due, so get it to me somehow. Understood? You'll be in school, right? Yes? Everybody understand that? Harry and Tony? You're going to, does everybody understand that even if we have school, we're going to have school on Thursday, correct? It's a half day, right? And you're going to get those assignments to me regardless, correct? Excellent. Okay, so we probably will have class. And then Tuesday, or what is it, Monday? Monday is your test. And do we have a date on that? Can somebody help me out with dates here? Does anybody have a calendar with them?
What?
Dates. What is Thursday's date?
27th.
Are you sure? 27th? Thursday the 27th. So what date are your assignments due, Iman?
Tuesday.
No. The assignments are due on Thursday the 27th, right? You sure? Excellent. And when is one more question. This is like a pre-quiz question. Yeah. When are your 2 quizzes? What date?
They're on
March
the
3rd, right? March 3rd, okay. Did you write that down in your book? Can you write that down? Rhoda, can you double check her to make sure she writes that down? All right, so are we all set? Now, let's begin the worksheet. First, shall we review what's on the board? Yes? We have, what are the 4 states of matter? 3 we really work with a lot. 4 we kind of observe, but we don't really work with it. Yes, Mary? Solid, liquid, gas, plasma. What's the dominant phase? What's the dominant state of matter? I'll give you a hint. Stars are made of it. Plasma, yeah. Do you ever see a match and wonder, what is that flame? Did you ever wonder, well, what is it? You can see it. You can kind of touch it. Not for too long, though, right? You can kind of touch it. But have you ever asked yourself, well, what is it? Because it ends. It has a boundary, doesn't it? Yes? It has a boundary. That's when it cools, it goes back into a gas. But when that gas is hot enough, it's a plasma, where the particles, the negative and positive particles, have no attraction to one another. It's a plasma. It's a high temperature gas, right? Called a plasma. So that flame that has a boundary is actually called a plasma. And stars are made of it. So matter, does it surprise you that most matter in the universe is in stars? Makes sense though, right? I mean, our sun is actually, relative to many suns, very small. It is. It's very small. Yeah? I'm going to get that off the wall in a minute, and we're going to do a little thing on suns, okay, and how small our sun actually is. That's a great set of photos, drawings, artistic renderings of our sun relative to other suns, other stars in the galaxy. Okay, now, so let's go over this a little bit. We have solid, liquid, gas. When you go from solid to liquid, you get, it's called what? Melting. When you go backwards from liquid to solid, it's called freezing. When you go from liquid to gas, it's called evaporation. And when you go from gas to liquid, it's called condensation. Okay? Now, when you go directly from a solid to a gas, such as dry ice, frozen carbon dioxide, where you go from a solid to a gas, yes? That's called sublimation. Now, has anybody ever seen dry ice? Raise your hand. Seen dry ice? What is the dry ice? What is that smoke? What is that smoke actually made of? What is that smoke actually made of? Anybody? Yes.
Carbon dioxide.
Carbon dioxide, yes, it's in there, but it's also frozen water vapor. It takes the humidity that's in the air and it freezes it, and that's the smoke that you see. Is not only carbon dioxide, but also water crystals that are being frozen in the air. How many people have ever been in cold climates? Raise your hand. Where you breathe and you go like this. What's that smoke? Frozen water vapor. Exactly. It's frozen water vapor. Yeah. So that smokiness is not necessarily carbon dioxide, although the carbon dioxide is in there, but it's also frozen water vapor. Yes? Okay. So when you go from a gas to a solid, it's called deposition. Actually quite a common legal term, deposition. Okay? Now, we have three states of matter that we study. We don't really study plasma a lot. Yes? But it's a solid, a liquid, and a gas. What has the most compact nature? A solid, liquid, or gas?
Solid.
A solid. What has the least compact nature? A gas, correct? Now, let's say, let me see where I can work here. May I move this, please? Let's see where I can work. I can work over on the right side of the board, okay? Can you make sure that I don't go off the board here? Okay? Now, hopefully we're gonna have time to do a lab on this. But let's say I take ice. I take a liquid, any kind of liquid. Yes? Any kind of liquid. We're gonna be taking a kind of wax, yeah? And we're gonna heat it. But let's say we do it to water. Okay, let's say that this is really cold. Let's say it's negative 20 degrees Celsius. Okay? We take water and we heat it up. When it starts to melt, this is a solid, but when it starts to melt, what's going to happen is when it starts to melt, is the temperature going to increase, decrease, or stay the same while it's melting? Yes?
It's going to stay the same.
How did you know that? That's excellent. Does anybody understand that? Mr. Nair said nobody's going to understand that, and I had somebody in class that right away said, boom, Sierra. I said it before? Oh, okay. So what happens is, as long as it's melting, as long as there's ice there and water, it'll stay the same temperature until it's all melted. Now it's all water. Now the temperature will start to rise again. Okay? Now the temperature will start to rise again. When will the temperature stop rising and stay the same, Jamie? Any idea? Now think about it. All right, think about it. I have pure water, right? Okay. I'm going to heat it. Have you ever heated water before?
Yes.
Yeah. What happens after you've heated it for quite a while? What happens, Jamie? It starts to boil, right. And what temperature does water boil at? 100 degrees. Does water boil at 101 degrees? No. It boils at 100 degrees. Does it boil at 120 degrees? No. It boils at 100 degrees. Does it boil at 99 degrees? No. It boils at 100 degrees. So as long as there's water there, what will the temperature of the boiling water be? 100 degrees. Does that make sense? Now, why do you understand that, but you don't understand the fact that water freezes at 0 degrees, and as long as there's water there freezing, it's going to be 0 degrees? Does that make sense now? Does that make sense now? If water boils at 100 degrees, Does water boil at 99 degrees Sierra? No. Joseph, does water boil at 101 degrees? No. Does water freeze at 0 degrees? Alyssa?
Yes.
Does water freeze at negative 20 degrees? No. Does water freeze at 1 degree? When does the freezing process, at what temperature is the freezing process for water, Vivian? 0 degrees. Say it with authority. Say it like you mean it. Say it like you knew it before you came in here. Say it like I'm asking you the silliest question in the universe. Let me ask it again. Let's see how you do this. You ready? All right. All right, here we go. Okay. Vivian, what temperature does water freeze?
0 degrees.
She said that with such authority. She should be teaching this class. I am intimidated by your knowledge and how you express it. Excellent. Well done. Now, so if I have water and it freezes, what temperature is it going to continue to freeze at? 0 degrees. And what temperature is it going to boil at?
100.
100 degrees. Now, can water get hotter than 100 degrees? Of course. And what's that called? What's the state? What's the gaseous state of water affectionately called? Sky? Vapor, yeah. But do you iron with vapor? Yeah. But what do you call it?
Plasma.
No, you don't call it plasma. I hope you don't call it plasma. I would hate to iron with plasma. That would be really weird. Yes?
Steam.
Are you guessing? Or are you saying with authority?
Steam.
It's steam. I like that. I like that. So it can get warmer than 100 degrees. Okay, and it's called steam. This is gas, this is liquid, and that's solid. This is solid liquid, this is liquid gas. This is evaporation. This is what? This is melting. Yes? Yes? Okay. So melting, freezing. This is evaporation, condensation. All right. So there you have the zones. How many zones are there? 5 zones, right? 6 zones. How many zones are there? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 zones. So you have solid, then it melts, then it's a liquid, then it's what? Then it boils, evaporates, and then it is a gas called steam. What do you call solid water? Ice, yeah, ice. Okay. So water has several names in the various states. Okay. Now, it doesn't gain heat, right? Does it gain heat? It doesn't gain heat? How does it melt then? Maren.
The warmth goes in.
So, but I thought you said it didn't gain heat. There's no change in temperature. What causes temperature? What causes temperature? Make it simple. What is temperature? A reading of what? Things. Collisions. You have a thermometer. Remember we went over this? You have a thermometer. Let's say it's made of alcohol, an alcohol thermometer. The ones with the red tip. You've seen them before, right? So you put that in water. The water hits it. It transfers the energy into the alcohol by hitting the bulb that the alcohol is in, correct? Yes? Yes? And what happens? The alcohol gets warmer and the temperature rises. Or the alcohol is more energetic and transfers its energy to the water, correct? So that both the thermometer and the water are in thermal equilibrium. That's a really, 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 really scientific sounding thing, isn't it? Can I write it right here? Thermal means heat. Equilibrium. Balance. Equilibrium. Things are the same, correct? So temperature is a matter of collisions. The more collisions, the higher the temperature, correct? All right. Kinetic theory says what? When matter has energy, it moves. When matter has a lot of energy, it moves faster. Okay, good. So what, therefore, if this is melting, so it's gaining energy. But what kind of energy is it gaining? Has anybody ever heard of potential energy? Yes? Potential energy is the energy of position. For instance, I have this. I have it down here, right? Now I'm bringing it up here. So, do you see how the potential to give up energy is greater up here? We call it the potential to do work. Energy. Do you see that there's increased potential energy here? Yes? Because if I let go, what's going to happen? It's going to move, right? How about up here? More potential energy? Yeah. What happens is this. I'm going to keep this very simple, okay? And this is really most of the answer. Are you ready? Are you ready? In these plateaus, there's no temperature increase because there's no increased collisions. So where is the energy going? It's not going into kinetic energy, because if it went into kinetic energy, there would be more faster movement and more collisions, correct? But it's not going into kinetic energy. So where's it going? Well, it's going into potential energy. How do you know that? Do you see that there's increased distance between the molecules going from a solid to a liquid? Do you see that? There's an increased distance. Yes? Increased potential energy. Do you see that? There's an increased distance. Going from here to here, I have an increase potential energy. Do you see that? As you go back the other way, you have a decrease. Yes? This way. Does that come on the screen? Does that come on the screen?
Yeah.
Yes? If I go this way, I have a decrease. Yes? You get that? So that's all it's doing. When it hits these plateaus, you're adding energy, but it's in the form of potential energy. See that? Does that make sense, Iman? Right? Make sense? It's actually very simple. What's kinetic energy? The energy of motion, movement. What's potential energy? The energy of position. It's the energy of position. Is the position greater with potential energy? If I go like this, am I increasing the position? I'm changing the position, so it's a higher position. It's a greater position to let go of energy. You see that? So that's what's happening. Yes? Makes sense? Let's go over the quiz now, all right? Let's see if we can answer this together. All right, the first one says, matter is made of what? What's matter? Matter is made of particle and kinetic theories of matter. It says that matter is made of tiny particles. Okay. Particles of matter are in what kind of motion? Constant motion. They are, aren't they? Are they in motion when you go from a solid to a liquid on this plateau? Are the molecules still in motion? Yeah, of course they're in motion. But you're not increasing the motion. You're increasing the distance going from a solid to a liquid. Correct? How'd you do? You did all right? I need the... Thank you very much. Okay. I'll let you know later, okay? Okay. Particles of matter are held together by strong forces, electrical forces. Very good. Electrical forces. What are molecules held together by? Particles are held together by what? Yeah, the bonding. Why is it electrical? Why is it electrical? Yes?
Because of the atoms.
Yeah, electrons, right? The bonds, correct? And other forces. Okay, what's next? It says, there are spaces between the particles that are very large compared to the what? What are the spaces between the particles are large compared to the particles themselves? Laura, you okay? Okay, you sure? Okay. All right. It says each substance has particles that are different from the particles of other substance. What are the two particles in matter? What are the two types of particles in matter? They're called... No. The particles in matter are either going to be elements or...
Isotopes.
Yeah, isotopes, etc. But aren't those the two major ones? This is ionic and covalent bonding. So they're either going to be elements or compounds, correct? So we could say, therefore, that each substance has particles that are made of different particles of other substances, right? Because a substance is either an element or a compound, correct? All right. Temperature affects the speed of particles. The higher the temperature, the particles will move. Faster, right? Put that down. Faster they'll move. Okay, now we have states of matter. It says fill in the chart below using the words definite or variable. May I erase this? I don't seem to have any paper towels up here. I'll erase this. Can you give me some paper towels somewhere? Do I have any somewhere? Right there. Are there any there? Back at my desk, do we have any? No? Okay. I'll erase this. Could someone go to the grocery and get some, please? This is not working. Yeah, please. Go ahead, yeah. Okay. Well, I'll have to wash that off in a minute. All right, so let's look at the table. Let's see if we can draw the table here. We're not going to be able to draw a table. Why don't we take a break? I'll come back. I'll put the table on the board, and then we'll answer it. Clear? Okay, so this will be particle and kinetic theories part 1, and then we'll do part 2. Clear? We're off.